All right, we are still graphing parabolas, quadratic equations, and we're going to start off by reviewing something that we have done before. So let's start by graphing this graph here. When we do that, we've been making a chart with points, and usually we did 0, 1, -1, 2, -2. So looking at this equation, you should know before even plotting any points that it's going to be pointing down, right? It's going to be more narrow, and it's going to shift up 3, okay? Based on that -2 in front means it's going to, negative means it's going to point down, the 2 means it's going to be more narrow, and the 3 means it's going to shift up 3. Instead of starting at 0, 0, it's going to be at 3 at the y-axis. Well, we can see that when we plug in 0, we do get 3. -1 is going to be -2 plus 3, which is 1, which that'll be the same. When we plug in 2, 2 squared is 4, so -2 times 4 plus 3 is -8 plus 3 or -5, and that's going to be the same. So we have 3, 1 is 1, and 2 is -5, and we get, oh, didn't do the trick. It doesn't always want to do the trick. There we go. Oh. Close enough. Okay, there we go. So we have our parabola. Notice our vertex, right? Our vertex is right here, is at 0, 3. And that is also the y-intercept. The y-intercept is the point that intersects the y-axis. And so notice the y-intercept is always when x equals 0. When any point on the y-axis is when x equals 0. And so it's that value at the end that doesn't have an x connected to it. Or in our case, it would be the c in a normal equation. It would be, if x is 0, everything else is 0, and you're left with that, and that would be your y-intercept. We already talked about how it compares, right? We said it points down, it's more narrow, and it shifted up 3. So today we are going to start graphing an equation that is in more standard form. It also will have an x term. Now, the number in front of the x squared, is the most important because it tells us, first of all, if it's going to point up or point down, right? Is it going to point up if A is positive? Is it going to point down if A is negative? The x squared, because it gets bigger faster, is really the driving force for our graph. And that A will also tell us if it's wide or narrow, okay? Now, we were just talking about the fact that C is going to be your y-intercept, because the y-intercept is when x equals 0, and if x is 0, everything will be 0 except for that C. We learned this before. The x-coordinate of the vertex is -b over 2a. And so we're going to use that, just like we did before, to find our x-coordinate of the vertex. And something we didn't talk about before, the axis of symmetry. We talked about how the parabola is symmetric, but our axis of symmetry is that, I abbreviate AOS, axis of symmetry is that line that goes down through the middle. And it's always going to be equal. It's a line, a vertical line is in the form x equals some number, and that number is going to be the x-coordinate of your vertex. Well, let's take a look at a problem. First off, without graphing, given a function, we want to find the vertex and axis of symmetry. So to find the vertex, remember we're going to look at x equals -b over 2a. So in this case, the opposite of b is negative 8 over 2 times 2. We get negative 8 divided by 4, negative 2. So that's our x-coordinate. Now we need to find the y. So we're going to plug negative 2 into our function. Remember, I'm replacing negative 2 or x with negative 2. So this is going to be 2 times negative 2 squared plus 8 times negative 2 minus 1. So 4 times, or 2, negative 2 times negative 2 is 4, times 2 is 8, minus 16 minus 1 is going to give me negative 9. So my vertex is going to be at negative 2, negative 9, and my axis of symmetry, which you can just abbreviate AOS, is going to be the equation x equals negative 2. So that is, remember, the axis of symmetry is going to be that vertical line. It's always going to be x is equal to whatever your x-coordinate of your vertex is. It's that line that is going through the center of your graph. All right, now you try this one. You can pause the video and try it on your own. So x equals negative b over 2a. This is going to be the opposite of 6 over 2 times 1. Negative 3. Now we're going to plug negative 3 into our function and get negative 3 squared plus 6 times negative 3 plus 5. It's going to give me 9. Oops, I guess that's minus 18 plus 5, negative 4. So my vertex is going to be at negative 3, negative 4, and my axis of symmetry is going to be x equals negative 3. That will be that vertical line. Well, now we're going to put it all together. I'm going to make my chart. We're going to start by finding our vertex. So x equals the opposite of b over 2 times 1 is 2. Let's find the value of the function at 2. So here's my 2. 2 squared minus 4 times 2 plus 7 is going to be 4 minus 8 plus 7, which is 3. So 2, 3 is my vertex. 2, 3 here. Okay. Is it going to point up or down? It's going to point up, right? So we know it's going to point up. Here's my vertex, 2, 3. My axis of symmetry is x equals 2. Oh, y-intercept. Y-intercept, that's when we let x equal 0. If x is 0, y is 7. So 0, 7. Now we know it's symmetric. So two spaces to the left, we're at 7. 2 spaces to the right from the vertex, we're at 7. So we know 4, 7 is also a point. We need another point, though, because we need 5 points to draw. So let's just plug in 3. That's going to be 9 minus 12 plus 7. That's going to be 4. So 4, 4. We can draw our graph. Oh, it worked. Yay. And we haven't talked about domain and range. Domain are the x values and range are the y values. Now, the domain for these are always going to be all real numbers. There are no, or we can write it with the fancy R. There are no limitations on x. We can put anything in for x. That graph's going to keep spreading out left and right, all real numbers. But the range means what y values are represented on our graph. And you can see the smallest y value is 3, and then it goes up from there. So we're going to say y is greater than or equal to 3. That's it. Okay, so a lot of what we've been doing is similar. Our graphs, something we should do when we write our axis of symmetry, let's draw it in. I forgot that. So we drew in our x. Oh, I'm going to take the arrows out, just like that. Okay, last one. For our graph, let's start with our vertex. And I'm going to make my little chart over here. So opposite of, just make sure it's not the same equation. It looked familiar. Okay, opposite of B, oh no, this is different. Over 2A is going to give me -4 over -4, which is 1. So 1, f of 1 is going to be -2 times 1 plus 4 times 1 minus 3 is going to give me -1. So 1, -1 is my vertex. 1, -1. My axis of symmetry is x equals 1. I'm going to draw that in so that we can remember our symmetry. Y-intercept, that's when we let x equals 0. When x equals 0, y is -3. That's so easy. And it's going to have the 1 to the right, 1 to the left. So -2 will also be -3. So, oh, I don't know if I wrote it on there. Let's see, 0, -3. Did I write it up here? Nope, I forgot to write it in. It should be 0, -3 here. We put it on our chart, but not in the graph itself, but we didn't write it in there. Now, domain, I said, is going to always be all real numbers. Looking at our graph, with that negative in front, we know it's going to point down, right? Let's finish graphing. So we need one more point. Let's plug in, oh, yikes, I can't believe I did that wrong. Let's start over. Whoops, sometimes Mrs. B makes mistakes. If you were in class right now, you would have caught me and got yourself a airhead. But I graphed this all wrong. Let's see, I don't know what I was thinking. 1, -1 is here. 0, -3, which means this is going to be +2, -3. There we go. What a recovery. So now 3, 3 we're going to plug in. So when we plug in 3, that's going to be -2 times 9 plus 4 times 3 is 12 minus 3. So that is -18 plus 12 minus 3, which is -9. So 3 is -9. We're still here. And it's, whoops, no, not there. It's going to be symmetrical. There. Let's draw this in. Whatever. Okay. And here is our axis of symmetry, which I wrote it right. Just didn't do it right on the graph. So now my range, notice what the biggest y is -2, right? Right here. And so y is going to be less than or equal to, I'm sorry, why did I say -2? -1. Y is less than or equal to -1. All my points on my graph on the parabola are less than or equal to -1 with regard to the y. All right, we took a couple detours there, but I think we finally got it right.